I'm going to show you how to read this EKG data. When I first received this data, I was not sure how to read it. The file name was nondescript.dat. So if I copy the file name here, say yes, that's what I had. And that doesn't explain to me anything actually. .dat, what's that, right? So I had to see what's available inside. So I'm showing you all these steps so that you can repeat it when you are given a black box of data that you somehow got to figure out what's inside, right? So when I did this, this told me what I could read. I could read either data or a grid. So normally I'll just replace the element with data here, but I will preserve the first line and I will show you what's in it. I will show you the grid first. And that's what I got. If you want to see more of it. And that didn't help, so let's see some more of it. And it's not showing anything. I doubt it's giving me any information. So I will just go straight to the data. This gets more exciting. And this is going to be my data. I will call it EKG data equals that and have it assigned. I am intentionally avoiding the semicolon so that you can see what's coming out from it. And this is what we got. So this is a whole bunch of lists. Then again, what a surprise. Everything is listed in Mathematica anyway. So these must be the data about the heartbeat. And I was told the sampling rate was 500. So if you see 500 sets of numbers, set of 500 numbers, that was duration of 1 second. So they were sampling 500 times per second. It sounds like a lot, but it's actually not that high. When you record your voice using computer, it's sampling at 44,000 times per second. Okay, so now let's make some sense out of this. What is this anyway? So the beginning part is a header. It's called header, but we will just read with our own eyeballs and we will not plot those. So I would want to see how long this header lasts, EKG data. So I want to see from, say, 1 to 100 and see what's in it. Let's make a column to see, make it easier. Okay, we hit the flash. So up to here is the header. So I say, let's primitively count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So up to 14th is spent on the header. So if I do 14 here, I should catch the last one, which is continuous data. And then go on with, that's right. So if I start reading from 15, then I will get the only the data. There we go. So let's get this here. So of course, the one that I skipped here, the data that was going from 1 through 14, of course, they're very important. That's what allows you to set certain parameters to see how to read this, when it was, and how many channels it has. Right there, this is stereo. Now that explains this, you see. This is not time versus the voltage. This is, both are voltages. Then you may say, then how do you know what time it was? I told you. It's 500 times per second. So by counting how many sample you had, you can tell how many seconds elapsed from it. So if you're looking at 1,500th point, then you're looking into 3 seconds after the beginning of the measurement. Then you may say, when did the measurement start? You're looking at it right here. So that's why you have all this data. Okay, so now let's see if we can read these things here. So we have established that the 15 is the starting point here. But how long is this list anyway? So EKG data, I want to know how long it is. It is this. So what I will do is I will extract I will just type it inside of EKG data. Okay, so I don't have to make this form here, but I will say EKG data only. I will say that. So what I'm doing is I am getting the only data portion out of this data set here. So I will suppress the output this time, and I got it. So this is the hot stuff that I have to analyze and do something with. But this, let me show you. EKG data only is a very nice, friendly numbers. Let's see, up to 30 only. So here. So we got this here. So let's, shall we plot this somehow? If you, you can do whatever you like on this, but let's get the just one channel so that we can plot it. So I will say EKG data only, first channel. Okay, how would you extract that from the EKG data only? Do you know? You do it by extracting the from all of them, that is all this list, only the first one. So that will give you the first one. So it should start with 3 to 7, 3 to 8, 3 to 8, 3 to 7. Take a look. 3 to 7, 3 to 8, 3 to 8, 3 to 7, and so on. So we got the first one only. Shall we see the second channel also? Actually, why don't I copy the whole thing here? Okay, and this time we are getting the second element of it. And when I do this, I get that. So I got this channels here, so now I'm free to plot. So let's do list plot. And let's just plot this. Then you get, I think, overwhelmed. There are too many. So let's see first 3 seconds. You may say, how do you know 3 seconds? I told you. It's 500 times per second, and there were 3 seconds. If you don't want to multiply, you can just put the operation right there. Okay, in 3 seconds, it really? It's so slow? Is it really possible? I thought our heart beat a few times per second. Maybe it's not true. I guess I'm just publicly announcing my ignorance here. Okay, now this time we will check the second channel. And looks like that. Okay, if you want to see both, then you can make a list of it, I think. There are so many ways of doing this, I keep forgetting which I believe. Let me see, if I just copy this over here. And let me get the first channel here. And I will put the curly bracket first to contain them. And here I will put comma first. And before the comma, I will put the first one. So I'm plotting the first channel and second channel in one. I think it is working. Notice that this is not the heartbeat that you hear, boom, boom. It's not. This is electrical signal from the heart and is taken from 2 points on the body. I do not know where they were. And what to do with this? I do not know that either yet, but I will let you know as soon as I find out from the doctor. Along the timeline, this is going to get faster, I think. Because these were measured right after the drug infusion. So the drug is affecting the heart rate, and you can measure how quickly it was beating just by seeing where the peaks are. And as you can see here, it was too much to show the entire length. How long was it? It was this long, right? So if you want to know how many seconds worth it was, just divide it by 500. Okay, I don't want to do that computation here. So it was taken for 317 seconds, which is too much for my brain to figure out. It was taken for 5 minutes. So during that 5 minutes, did the heartbeat go up, down? Now you have to figure that out. You have all the numbers here. So with it, you got to somehow figure that out. That's the mission for this project.